Alright, a dog trainer is fencing in an enclosure. We have the shaded region here, and they're also going to have two square-shaped storage units on either side to put equipment and other materials. And we can make the length of it up to 100 feet, but no longer. So let S represent a side length in feet of one of the square storage units. So I labeled them all, S, 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 S. Forgot one here, but they're all S. Label the width in the diagram. Explain your reasoning. So the width is really kind of our height here, so it's S. It's S because all sides of a square are the same length. Then write an expression to represent the length of the enclosure, so the length this way. Well, it's 100 minus S over here and S over here, because we have it on both sides, so 100 minus 2S. It can be at most 100 feet, but there are two square storage units on either side with the length of S, so 2S, so that's why it's 100 minus 2S. And write an expression to find the area. Well, to find the area of a rectangle is length times width. So our length is 100 minus 2S, our width is S, so we multiply the two. So S times 100 minus 2S. We can write it a different way, and we will in a second. So they tell us about the distributive property, not that we already don't know, but you can distribute over parentheses. So we're going to rewrite this equation, distributing the S in, so it's 100S minus 2S squared. And just so we put it in the form that we're used to, I'm going to put the negative 2S squared first plus 100S. Remember, this 100 is positive, the 2 is negative, so we make sure we have the signs to go with it. Now we're going to write it as a function, A of S, in the standard form. So A is the area. S is the side length of one of those squares. So A sub S, or A of S, is kind of like our f of x. A is the name of our function, S is our variable, so we use S here. Now what I forgot to do is label A, B, and C. A is negative 2, B is 100, and C, well, there is no number by itself, so it's actually 0, and that's fine. Identify the independent and dependent qualities and their units. Oh, I didn't do the units. But the independent, the one that doesn't depend on anything, is the side length of the storage units in feet. The one that's dependent, that really focuses on the other one first, is the area. So the area of the dog enclosure, and that would be in feet squared, is A of S, or our Y value. And that's feet squared, don't know where the F went. So here's what happens as the square storage units get bigger, 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 and bigger. Well, what happens to the area of the enclosure? Well, it shrinks. And what would the graph of the function look like? Well, the graph is graphing the Y values, or our area. So our area is going to keep decreasing. So we graph it. Now we need to scale it. So we need to really figure out what our graph looks like first. So if we're using the 84 or the Inspire, we're going to do it the same way. It doesn't matter what form you put it in. So we'll do negative 2, and we can't put in S. We have to use X squared plus 100X. And delete that. So when we graph, I put minus instead of negative. So when we graph, we get something that looks, well, we can't even see anything. So to start, I'm going to hit the window, zoom, and do zoom fit and see what it does. Alright, we're starting to see, we still can't see the vertex. We see 1, 0, but we don't see the vertex. So I'm going to go to my window. I need to see farther to the right on the X value and farther up. And since area is our Y and the length of the shed is our X, those can't be negative. So we're not going to look at quadrants 2, 3, or 4, just quadrant 1, because they both have to be positive. So this is where our domain and range are not the same thing because it's a word problem now. So I'm going to go to Window, and then in the X, I'm going to go to -10, but I'm going to go up to, I don't know, let's try 60. The Y min, I think -1200 is kind of low. We don't need that far. I'm going to do a -100. And then my Y max, and it's supposed to be a negative, not a minus. I'm going to go up to, I don't know, 2000 and see what we can get there. Oh, we got our parabola. So what do we need to know? Well, we need to find our vertex and our zeros so we know what to graph on our coordinate plane. So second, trace, do our 0. So left bound. So just click it somewhere to the left of a 0. I'm going to go to this far right 0. Take a guess somewhere in there. Up 50, 0. Now obviously our other 0 is at 0, 0, so I'm not going to find that. But I do need to find is our maximum. So second trace, do maximum. And again, just arrow somewhere to the left of our vertex. Somewhere to the right. And then just take a guess somewhere in between. Oop, 25, 12, 50. Now, if we're using this calculator, of course it's the same thing. We go to graphs, -2x squared plus, whoop, don't know what happened to that, plus 100x. Again, we can't really see what's going on there. So Windows settings, and I've already kind of done this, so I know what it should be, but really you just got to keep messing with it until you get something that works. And there we go. So we can find, so analyze graph, we can find our zeros. You see it's 50, 0. If, analyze graph, maximum. Notice we have this, 1.25e plus 3. That is scientific notation, meaning 1.25 times 10 to the third. Move our decimal place 3 times, so it's 1250. And again, our other 0, 0, 0, we don't need to really find that. So we have our points. And 0, 0 is also our y-intercept, so we don't need to find anything else there. So when we're graphing, we just have to find a scale that makes sense. I decided on our x-axis, the length of the square unit, I'm going to go by, I went by each one of those lines was 4, and I labeled every 8 because I knew I'd get up to 50. I would at least want to get to 50 because that's where my second 0 is. Now the y value, I know the maximum is 1250, so I went up to 1500. So each one of these is 75. And I plotted my zeros and my vertex, and then I graphed them, and I labeled. Well, almost. I forgot to label my x-axis. So this is the length of a side of the storage in feet, where this is the area of the enclosure in feet squared. So we have our graph. And you could have done it in factored form, in standard form, or vertex form. Either way, you're going to get the same thing. So think about the possible areas of the enclosure. Is there a maximum area that the enclosure can contain? Yeah, there's a maximum area because this is a maximum point. And our maximum area is our y, so our y value, the maximum area, is 1250 feet. Now using the graphing calculator, find the maximum. Well, we've already done that. So what does that mean? Well, when the square storage units are 25 by 25 feet, so the side length is 25, that's what X or S means in this situation. The area, the Y, is 1250 feet squared. Now we can find this by doing our cheat, negative b over 2a. So it's negative 200 over 2 times negative 2. So negative 100 divided by negative 4 is positive 25. And we can substitute that in to find our y value. So we get 1250. Or just use their calculator. Either way, we're looking at our vertex, our maximum. Now we're going to look at the same thing, but now we're going to have a slightly different problem. So the handshake problem. So the idea is that every employee shakes everybody else's hands. So if there's 2 employees, they shake hands, and there's only one shake hands. If there's 3 employees, represented by the 3 dots, we connect them. This person will shake with this, and this will shake with this, and then these 2 will shake. So you're just connecting all the dots that you can. So there's 3. If there's 4 employees, we have 6. So if we want to do that for 5 employees, 6 employees, and 7 employees, draw out 5 dots, 6 dots, and 7 dots, and connect them all, and count how many lines you have. With 5, we had 10 lines. With 6 dots, we had 15 lines. And with 7 dots, we had 21 lines. So here's our pattern. 2, 1, 3, 3, 4, 6, 5, 10, 6, 15, 7, 21. That's just what we got from counting. Now, to find our pattern, well, how do we get from 2 to 1, or 3 to 3, or 4 to 6, or 5 to 10? Well, a couple different ways we can kind of look at that. But what it boils down to is we're multiplying a number, the number of employees, by 1 minus itself. So 2 times 1, and then divided by 2, because we don't want to count each line twice. So 2 times 1 is 2, divided by 2 is 1. 3 times 2 is 6, divided by 2 is 3. 4 times 3 is 12, divided by 2 is 6. So the way we represent that is a number, n, times n minus 1, so the number less than that, and then divided by 2, because we didn't want to count them twice. So here's our expression, n times n minus 1 over 2. Now, we can distribute the n, and then we can split this up. Remember, that's like saying 1 in front of both of those, so we'll just split it up into 1 over 2n squared minus 1 over 2n. We graph just those points that we already had, so x is the number of handshakes, and y is the number of people. Actually, I have that backwards. X is the number of people, and our y is the number of handshakes. And now we don't want any negative x or y values because we can't have negative people and we can't have negative handshakes. So we start at 0, 0. We didn't have that in our table, but if you plug in 0 here, we get 0. And if there's no people, there's no handshakes. So the absolute minimum is 0, 0. 0 people have 0 handshakes. Describe the domains in terms of the function for both of these. Now the negative 2s squared plus 100s, let's go back to our graph, all the way here. Notice our x value has to be positive. Our x or our s has to be positive because it's the length of a side of the storage unit. It can be between 0 and then 50, because after 50, if we have an x value of 50, our y, our area, is below our x-axis. Also, if you think about this, if both of these square units are 50, well, together they make 100, and that's as wide as we can make it. So there'd be 0 area of the pen. So that's why it's 50 side length, 0 is the area of the pen. So our x maximum, we can go from 0 to 50, because after that we go negative. Our y, if we're talking about our range, well, it's 0 if we don't have this area in the middle, up to 1250, because that's our maximum. So we're just looking at the domain. So for our dog place, it's at 0. We could have none, up to 50. And I guess we can have 50 as well. Now our handshakes, we can have 0. We can have 0 people. There's no handshakes. It's kind of boring. And we can keep going. If you look at our graph, this keeps going up and up and up and up. So we can have more and more and more and more people. There's no limit on how many people. So we're going to have tons and tons of handshakes as well. But we're just talking about our x. So it's from 0, including 0, up to infinity. So 0 to infinity people to shake hands. Now, how can we tell if a graph opens up or down? Well, if A is positive or is greater than 0, it opens up. If A is negative, it opens down, because that's when it reflects horizontally. And we learned that when we did our transformations. How can you tell if it has a minimum? Well, it has a minimum if we don't reflect it, meaning A is positive. It would have a maximum if it was reflected horizontally, so A would be negative. And that's how we put it all together.